Fruit, a food group we often love to turn into dehydrated on-the-go snacks. But here's the problem. 85% of the dehydrated food you eat is dried using hot air ovens, which sucks the nutrients straight out of that dried mango you love so much. Not to mention, it's an energy-guzzling technique which isn't exactly great for the environment. But USU researchers might have the perfect solution: sunlight.
Part of the ultraviolet and infrared radiation from the sun is selectively absorbed as it passes through certain regions of the atmosphere.
By sort of narrowing the light we get from the sun, we are able to obtain dehydrated products like fruits in a more efficient way. Food dehydration is one of the most effective food preservation techniques, as we know. However, the big drawback it has is its energy intensity. It's a very energy demanding process.
So how energy demanding are we talking about here? Well, let's think of it in terms of energy efficiency. A high energy efficiency essentially means using less energy to perform a task. Simply put, the more we focus on efficiency, the more energy we save and the more benefits we see.
UVA dehydration can have energy efficiencies between 50 and 60%, and it preserves nutrients as opposed to other dehydration techniques.
The most common food dehydration method, hot air drying, has an energy efficiency varying from 10 to 30%. Pretty low, right? Well, it gets worse.
Freeze drying is the least efficient food dehydration technique. It only has an efficiency of 1%.
We focus mostly on the hydration aspect and also the effect of irradiation on other chemical and physical aspects of food products, such as texture, consumer acceptability, color, aroma, flavor. The texture is much chewier compared to hot or dried samples, which are brittle. Compared to other techniques like hot or drying and freeze drying, this technology consumes less energy and the carbon footprint will be lower because of the lower energy consumed in this technique.
Another benefit is the length of the process. Other techniques may require days to complete the process, and we can reduce the dehydration time to a few hours depending on the type of product.
So at this point, I think it's fair to consider UVA light a real contender in the food dehydration industry. Unlike its competitors, it preserves nutrients, it saves energy, it takes less time, it costs less, and maybe most importantly, it produces a food product that's superior in appearance and nutritional quality.
Many raw materials in the food industry need to be dehydrated, so anyone who is a supplier for the food industry may benefit from this technology. Beyond the food industry, we believe any industry that requires biological samples in their line of production may benefit from UVA dehydration.